So rate of work, essentially, how long does it take you to complete a given task? And today we're going to be looking at, well, what if one person takes this long and one person takes that long? Well, what if they work together? How long would it take them together? Those kinds of questions. So the first example we have there is Tanya and Justine, who own a cruise boat that takes people out to the Atlantic Ocean to show them how lobsters are caught. At the end of the day, Tanya and Justine take turns cleaning the boat for the next day's cruise. Tanya is older and cleans the boat in about 2 hours. It takes Justine 3 hours. So the questions below help walk us through understanding this type of problem, and then we'll get the solution at the bottom. All right, what fraction of the boat does Tanya clean in 1 hour? Well, if it takes her 2 hours to clean the whole boat, then in 1 hour she cleans half of the boat. So her rate of work is half of a boat per hour, or one boat per 2 hours. Okay? Justine takes 3 hours to clean the whole boat, so in 1 hour she has cleaned 1/3 of the boat. So her rate of work is one boat per 3 hours, or reduced in terms of hours, 1/3 of the boat per hour. The next question says, what is the sum of these fractions? So we'll just set it up. 1/2 plus 1/3. In order to add and subtract fractions, I need a common denominator. So I'm going to express both of these fractions as a number over 6. 1/2 is the same as 3/6. I have not changed the value of that fraction. 1/3 is the same as 2/6, but now my fractions are both expressed as sixths, so I can add them up. I have 5/6. What does this tell us? In 1 hour, if they worked together, it's that plus sign there, they would clean 5/6 of the boat. Well, that's not super helpful because we need to know when that boat is going to be cleaned. How fast can they clean the whole boat together? And I'll just show you one way of doing it here, and then in example 2 we have a different way of doing it. One way of doing it is using a strategy called proportions. Basically what we've done is we've set up a rate of work here. We know that they have cleaned 5/6 of the boat in how long? In 1 hour. Okay? In 1 hour. Now, I'm going to convert this to minutes so that we can see how long it's really going to take them, because they really only have, look, if they've cleaned 5/6, they only have 1/6 left to clean. Okay? So we need to figure out how long is it going to take them to clean that last 1/6 and then add it to the hour. But an easy way to do that is just to say, okay, in 60 minutes they've cleaned 5/6 of the boat. How long is it going to take them, T, time, to clean the whole boat? This is called a proportion. The ratios of the time it takes to clean a boat and the time it takes to clean a boat are the same. Okay? For a portion of the boat or the whole boat, the rate of work doesn't change. So the rate of work is equal. If I put the number 2 here, I'd basically just be saying, okay, together, how long does it take them to clean 2 boats? Or 3 boats? Or a whole fleet of boats? Okay, but for this situation, I only need them to clean their own boat. And we already have a completed ratio, which we can then put into the proportion. Now, we've learned a couple of different ways of solving proportion problems. Because I have a fraction up here, and it might get a bit messy otherwise, I'm going to use the cross product, which tells me that in any proportion, the top times the bottom, 5/6 t, is equal to the bottom times the top. And now I'm just solving like any other algebra problem. I need to, t is being multiplied by 5/6, so I could divide both sides by 5/6, Or, now we're getting into some good stuff, I could multiply by the reciprocal of 5/6. I could multiply by 6 over 5, because 6 times 5 is 30, and 5 times 6 is 30. This would eliminate and just reduce to 1t. So I'll do that to both sides. Then over here we said these guys will cancel out, leaving us with just t. And on the right side we have 60 times 6, which is 360 over 5, which reduces to 72. And remember, we were doing this in minutes. So using proportions, we can set it up. We have a rate. They'll clean 5/6 of the boat in 60 minutes. How long will it take them to clean the whole boat? How many minutes? Okay? It will take them 72 minutes to clean the boat together. Alright, example 2 is going to be very similar, but we'll use a slightly different method. Example 2. After the restaurant closes, Roberto takes 2 hours to clean it. Bill is new to the job and takes 4 hours to clean the restaurant. How long would it take them if they worked together? So again, this being a unit on algebra, we could solve this using proportions like we did before, or we could solve it using an equation. And one of the key steps to using an equation here is to introduce a variable. So we're going to let x represent the time it takes. Let x represent the time it takes to clean if they work together. Okay, and we're dealing with hours, so if we want, we could say let x represent the time in hours it takes to clean if they work together. Well then, let's think about Roberto. The time it takes in hours if they work together. It takes Roberto 2 hours to clean the whole restaurant. So in 1 hour, he could clean half of the restaurant. So basically, if he worked for 2 hours, he would get 2 over 1, which would be 1 whole restaurant cleaned. Okay? If he worked for 1 hour, he would get half of the restaurant cleaned. And that makes sense because in 2 hours he cleans the whole thing. Alright? Now we have our friend Bill. He's new to the job. It takes him 4 hours. So however long he works in hours, you can divide that by 4, and that's how far he's gotten. So if he works for 3 hours, he'll be 3/4 done the work. If he works for 1 hour, he'll be 1/4 done the work. And if he worked by himself for 4 hours, he'd have the whole restaurant clean. He wouldn't need Roberto's help. But we want to find out how long it takes if they work together. So if they work together and they clean the whole restaurant, how many restaurants have been cleaned? Well, 1. So in this case, our equation ends up being Roberto's rate of work plus the amount of time it takes Bill, or the fraction representing that, is equal to 1 clean restaurant. Okay? The rate that we got, the fraction that we got for Roberto and Bill, we add those up, we're going to get a clean restaurant. Now, easiest way to solve this algebraically, let's multiply all the parts by 4. Multiply each term by 4. 4, 4, 4. So in the rules of algebra, if I have an equation, that's a math statement with an equal sign, using variables, I can multiply everything by the same thing, and then it doesn't change the value of it. Okay? Another way to look at that would be if I had just done brackets around this whole left side and then put a 4 out front, you would know to distribute the 4 as a multiple to both of these terms. All right, well, let's take care of this. What does multiplying by 4 do to this first fraction? Well, it gives me 4x over 2. This factor of 2 will cancel out one of the factors of 2 from this 4, just leaving us with 2x. And over here, I'll have 4x over 4, or 4 over 4x, which is just 1x. On the right-hand side, 4 times 1 is 4. And now this problem is pretty simple for us to solve. We're going to group our like terms. We have 3 x's. And now we need to isolate x by dividing both sides by 3, which is going to give us a value for x of 4 over 3. Now let's double check to see what that means and if we like the way our answer is being recorded. X is the time in hours it takes to clean the restaurant. So it's going to take them 4/3 of an hour, or 1 hour and 1/3 of an hour. Let's translate that into hours and minutes. If we're going to use our statement, we have 1 hour and 20 minutes. Okay? Together, they can clean the restaurant in 1 hour, 20 minutes. Okay? So again, we let x represent the number of hours, the time it takes for the job to get done if they work together. Roberto can do half of the restaurant in 1 hour. Bill can do a quarter of the restaurant in 1 hour. And then we just simply say, okay, what if they work together? They'd clean a whole restaurant. So Roberto plus Bill equals 1. Use our algebra skills by eliminating these fractions by multiplying everything by 4, and then solve for x, expressing our final answer in a statement that relates back to the question we were actually asked. Okay? Just 2 examples for you to go off of here today. Your practice problems are from page 261, numbers 1 through 9.